Welcome back to my YouTube channel. In this video, we will be talking about exponential and logarithmic functions. Okay, let's start with exponential rules, which only applies to multiplication and division. Here, we will start with same basis. Okay, the first rule would be a to the power m multiplied a to the power n. Then the answer would be a, and then the exponents would be added together. So here, the operation is multiplication, and a is called the base, and m and n are called the powers or exponents. So once more, a is the base. So as you can see, they have the same bases. M and n are the powers or exponents. The operation here is multiplication, okay? And the action is adding these two exponents together, okay? So let's do an example. X to the power 3 multiply x to the power 2 would equal to x. The base is x. The exponents will be added together, okay? Now let's move to rule number 2. Here we have the two bases are again the same. It's both a. The first one, the exponent is a division, and then the first exponent is m, the other one is n. And here the answer would be a, the denominator exponent, subtracted from the denominator exponent, okay? So the base are still the same. The operation is division. And then here, the action taken on the exponent is subtraction. And as you can see, again, the bases are the same. So an example would be x to the power 6 divided by x to the power 2 would be x. The exponent would be subtracted from one another. 6 minus 2 would be x to the power 4. Okay, what if the bases are not the same and they are different? So let's say the first thing we will do would be a times b, the whole thing, raised to the power m, okay? Here, there are two different bases, a and b, okay? And the exponent is m. So the action here would be, right? The action here would be, we will distribute the power over every individual element in the bracket. So here I have two different elements, and so I will distribute the exponent to each of these, right? So an example would be 20 multiplied by x by y, the whole thing, the whole bracket, it's raised to the power 1 over 2. And remember, the power or the exponent can be any number. It can be like any real number. So here I have three different bases, a constant, x and y, but all of them are raised to the same exponent. So here, what will happen is that the exponent or the power will be distributed to every single element in the bracket. Okay, now let's talk about the other one, which is like a division, and the whole thing is raised to the power m. So again, the exponent m will distribute, and a over b, the whole thing to the power m, would be equal to a to the power m over b to the power m. So once more, the power will be distributed. Let's do an example. So let's say the fraction here is 2 over 3, and then the whole thing is raised to the power 2, which would be equal to, the power would be distributed to the numerator and denominator equally. So that would be 2 to the power 1 over 2 and 3 to the power 1 over 2. And we know that when the power is 1 over 2 or 0.5, that means the square root. So that would be the square root of 2 over the square root of 3. And this answer can be further simplified, but for this video we will stop here and we will discuss it how to simplify it further in the other videos. Also, you can report the final answer in decimal format, so you should follow what the question is asking you. Are they asking for decimal or just fraction, radical format, simplified format? You should follow whatever the question is asking you. These are the scenarios with different bases, and for the rest of the video I will explain the general rules for exponents, which is very handy and very important, and you should be really mastering these rules. So yeah, let's talk about the general rules. The first rule would be anything, a constant, a variable, whatever raised to the power 0, it's 1. The second rule would be, okay, now rule number 3, which actually is the same. It's actually the expanded form from rule number 2. So it would be 1 over a negative exponent. And remember, the negative exponent always flips. So if it's 1 over, it will turn into a to the power n. Okay, so I brought 2 examples. 1 over 2 to the power negative 3. So the exponent is negative, so it turns into 2 to the power 3. Another example, here I used a variable. The exponent is negative, so it turns into a positive, but the fraction would be flipped. Here the fraction is 1 over, so when it's flipped, it would be y over 2. These are very important properties of the logarithm, and they are used very extensively when you are dealing with exponents and logarithmic functions. So another important property, which I usually put a star for my students, so would be a base raised to the power m, and then the whole thing raised to the power n. So here it would be the base, but the exponent would be multiplied by one another. So an example would be x squared. The whole thing is raised to the power 3. So it would be x, and then the exponent would be multiplied to one another. Another one, 2 to the power negative 1. And as I just mentioned, the exponent could be any number, any real number. So it's negative 1, and then it's raised to the power 3 again. So the final answer would be 2 to the power negative 3. And I want to explain a little bit about this one, because there was a very similar rule in the beginning of this video. If you remember, it was a to the power m multiplied by a to the power n. Okay, so in the beginning of this video, I brought you this property of the exponent, which is totally different from this rule, but for some reason students get so confused. But I want to elaborate on these two a little bit. So here the bases are the same, and as I just mentioned, the exponent will be simply added to one another. But on this particular one, okay, so there is one base, it's raised to the power m, and then it's raised, the whole thing is raised to the power n. Okay, so take a look at this one, for example. Okay, and let's break it down, let's expand it. So x to the power 2 to the power 3. So that means it is multiplied by itself, right, 3 times. And if I want to find the answer, now it follows this rule. because the bases are the same, okay? The bases are the same, so the exponents should be added together. What are the exponents? 2 plus 2 plus 2, which is 2 plus 2 plus 2, which is equal to x. 3 times 2, which is x to the power 6, right? And that's why we multiply. We multiply. See? Here, we multiply the exponents. I hope this clarify a little bit and help you to avoid making such mistakes, because I've noticed that so many students confuse these two rules together. Okay, another rule would be a to the power negative m divided by a to the power negative n. So the bases are both the same and it's a, and as you can remember, both of them have got the negative exponent, so that means it will flip, right? So that would be a to the power n divided by n a to the power m. So an example would be this one, 2 to the power negative 3 divided by 2 to the power negative 5. So it would be 2 to the power 5 divided by 2 to the power 3. And as you can see, they are same bases division. So I just write the base and subtract the exponents, and it turns out to 2 to the power 2, which is equal to 4. So next rule, it would be a fraction raised to the power negative m. So in the fraction, the numerator and denominator could either be constant, different variables, or a combination of both. It could be anything. Because the power is negative, so again, it's flipped. Because it's flipped, so the base, which is a over b, which turns into b over a, right? And then the exponent will turn out to be positive. So an example would be 5 over 7 to the power negative 2. It will turn into, flip the fraction, 7 over 5. The power would be positive, 49 over 25. Another important rule is when you have, let's say, x over m, and then it's under the radical, but then the root is n, okay? So this is a very important rule. So this is actually called the index, okay? So the n is called the index, right? M is the power as before, and a is the base, okay? So it will turn into a, and then the power would be divided by the index. So you can also write it in these two formats, a to the power m divided by, raised to the power 1 over n. Because here, as you could remember, according to one of the rules, m would be multiplied by 1 over n, which would be exactly the same thing. And even here, if you multiply these two, it would be equal to this as well. Okay, last rule that we will be discussing would be a times b, then under the radical sign, but the index could be any number, it's n. So there are two different bases here, as we can remember. So it would be the power here is 1 for both of them. So it's actually an expansion of the previous rule. So it would be 1 over n, okay? So it turns, according to one of the rules, we will distribute the power. So it would be a over a to the power 1 over n multiplied by b to the power 1 over n. Okay, let's continue our discussion with some examples. So right now, I'm giving you some examples and I want you to convert to the indicated base. So let's say the first one is 81, which is the base, raised to the power 2x. 81 is the base, 2x is the exponent, and I want you to change the base once to 3 and the other time to 9. Okay, so let's do it together. As you know, 81 is equal to 9 to the power 2, or let's say 3 to the power 4. So from here, we can say 81 to the power 2x. We change the base to 3, from 81 to 3. 81 is equal to 3 to the power 4. So that would be 3 to the power 4 as the base, and then the exponent doesn't change. And if you remember, it was one of the rules. So here, sorry, the two exponents will be multiplied to one another. Okay, so in the next part, the question is asking, change the base, okay, to 9. So 81 is 9 to the power 2, okay? So it will, again, the same rule, it would be 9 to the power 4x. And an interesting property. So 81 to the power 2x would be equal to 3 to the power 8x equals to 9 to the power 4x. So here you can see like the bases have changed and the exponent have changed as well, and they can be easily converted from one to another, and they are all equal to one another. Let's do another example. So here I want you to change, the base is 125, so I want you to change the base to 5, please. Take a moment, maybe you can stop the video and then do it on your own and then check your answer. Base is 125, the exponent is 1 over 2x, and the question is asking to change the base to 5. So let's do it together. 125, right, is 5 to the power 3, okay? So now I substitute, here I substitute 5 to the power 3, and then the exponent is 1 to the power 2x. And as you can see here, the exponent is a combination of number and a variable. So here 5 to the power 3 is the base, and then here this is the exponent. So according to the same law or rule, it would be 3 to the power 2x. Okay, now let's do another one. This is very interesting because here we have 4 times radical 2 times 32 to raised to the power 2/3. So here, if you look closely, they're asking the base to be changed to 2. But I want you to pay attention here to something. Here, the 4 is a constant and the power is 1. Then I have radical 2. Then I have 32, which is raised to the power 2 over 3. So each of these can be converted to a base of 2, but they would have very different exponents. Let's do one by one and then substitute them back, okay? So 32 is 2 to the power 5. Radical 2, square root of 2, is 2 to the power, remember here the power was 1 and the index was 2, so it would be 2 to the power 1 over 2, and then 4 would be, can be written as 2 to the power 2. So here in the next step, I just substitute everything back in. So here, instead of 4, I put 2 to the power 2. Instead of a square root of 2, I put this one. And instead of this, I put this. Okay, so let's simplify it one step. This thing wouldn't change. This thing wouldn't change. But this part, the 2 exponent would be multiplied to one another, and it turns into 2 to the power 10 over 3. Okay, so from here to here, as you can see, there are 3 different bases, but they are the same. All 3 bases are 2, but one of them have got the exponent 2, the other one 1 over 2, the exponent of the third one is 10 over 3. So that means I write the base, and then what I do, I will add all these 3 exponents together. So that would be 2 plus 1 over 2 plus 10 over 3. okay? And for those of you who cannot remember how to do the common denominator for fractions, I'll try to explain it. Just a reminder. So 2 plus 1 over 2 plus 10 over 3, we do a common denominator. So here the common denominator would be 2 times 3, which is 6. Okay, as you know, here the denominator is 1 for number 2. So 6 divided by 1 is 6. Times 2 would be 12. Now 6 divided by 2 is 3. 3 times 1, 3. 6 divided by 3 is 2. Okay, 2 times 10 is 20. Then the next step, we just add all these three numbers together. 12 plus 3 plus 20, 35. And the common denominator would be written down. So from here, we just substitute. Instead of writing these three fractions, we just substituted with 2 raised to the power 35 over 6. Okay, let's continue this question. Now I give you another example, and I want to change everything to base 2. So here, the first one has the base 4. The second one, the base is 256. The third one is a fraction, and it's 1 over 8. So let's start considering each one separately. Okay, so 4 would be 2 to the power 2. 256 would be 2 to the power 6. And then 1 over 8, okay, this is a little bit tricky. That would be 1 over, instead of 8, I put 2 to the power 3. But remember, 1 over an exponent, a base to the power an exponent, it will change into, it will flip with the negative exponent. Okay, now what I'll do, I go back and I substitute all the values. So instead of 4, I put 2 to the power 2. Then it's raised, it should be raised to the power negative 2. Instead of 256, I substituted with 2 to the power 6. Then remember, it should be raised to the power 3 again. Okay, instead of 1 over 8, I put 2 to the power negative 3, but then it should be raised to the power 3 afterwards. Okay, now I simplify a little bit. So this one will change into negative 4. This one will change to 18. And this one will change into negative 9. And here I have 3 different bases, which happen to be the same bases, different exponents. So I just write the base and I add all these 3 numbers. Negative 4 plus 18 would be 14. 14 negative 9 would be 5. So the final answer is 2 to the power 5, which is equal to 32. Now let's do another one. This is 25 over 49. So the base is a fraction, and then the exponent is a combination of constant and a variable. And I want you to change the base to 7 over 5. Okay, so this one is also a little bit tricky because here, first of all, the original base is a fraction, and then they're asking you to change the base to another fraction. So let's see what we can do together. Okay, so 25 over 49, I can rewrite it as 5 over 7 to the power 2. Okay, but if you look closely, they want the base to be 7 over 5, not 5 over 7. These are actually reciprocal, or they are flipped. So what I'll do, I flip this one. Okay, I flip the base from 5 over 7 to 7 over 5, and I give a negative sign to the exponent. Okay, so once more. So 25 over 49, I can write it as 5 over 7 to the power 2. But if you look closely, they want a different base, which is actually the reciprocal of this base. So what I can do, I can flip the base and I change the exponent to negative. All right. So now the next step, I simply substitute. So here 25 over 49, I put it as 7 over 5 to the power negative 2. And here it should be raised to this power. Okay. So I just put the base and I multiplied these two numbers. So negative 2 times 0.5 would be negative y. And the base would be 7 over 5. That is what was required. Okay, next one. Here again, the exponent, the exponent is 2 plus 4x, but the base is a fraction. And they're asking us to change the base to another fraction. So let's see what we can do together. So here, what I will suggest is 64 over 125, change it into 4 to the power 3, because 64 is 4 to the power 3. 125 is 5 to the power 3. So from here to here, because the base, the exponents are the same, I can write it as a fraction and then give the common base. So 4 over 5 to the base 3. Okay, and the base is exactly as what is required. So here, what I'll do, I just substitute. So instead of 64 over 125, I substituted with 4 over 5 to the power 3, and then the base, the exponent is a combination of number plus another term. So the exponent here is a little bit different from what we experienced so far. The exponent is binomial. It's got two different terms. One of them is a constant, the other one is a variable, right? And with a coefficient. So here it doesn't matter. Remember what I told you, the exponent could be anything. So you write the base and you just simply multiply these two exponents together, so it would turn into 4 to the base doesn't change, 4 over 5, and then the exponent will change into 6 plus 12x. So this is part 1 of the exponent and logarithmic function. So I hope you enjoyed this video. Don't forget to subscribe to my channel. I will continue on this topic with more advanced questions and another video only on practice question on this topic. See you next time. Bye.